This first slide here just shows you the difference between a growth problem. A growth problem is going to increase over time. And what you're going to notice about that, the important thing here, I'm going to circle it, is that K, which is part of the equation, K is going to be greater than or equal to 0. If it's a positive value for K here in the equation, you know that it's going to be a growth function, that it's going to increase over time. When you look at it and it has a negative value, we call that exponential decay. It's going to decrease over time. And the really interesting thing about the exponential decay problems is that they're going to get closer and closer to hitting the x-axis, but it's actually never going to hit the x-axis. It's never going to hit 0. So what you need to understand about this equation down here at the bottom is what each of these letters mean. A is the new amount of whatever we're talking about. It could be people, it could be the amount of a substance after time t. A sub 0, those of you who have taken physics, you talked about V sub 0 before. What does V sub 0 mean?
That has to do with... velocity.
4.5. What kind of velocity? V sub 0 is the initial velocity. So A sub 0 is the initial.
Isn't that like V naught or something like that in British? Yeah, it is.
Initial amount.
It won't let me.
Try again. Close out of Schoology.
I did.
Come back in.
Unable to load file.
K is your constant of growth. And T is time. Time today could be measured in seconds, it could be measured in minutes, it could be measured in hours, days, months, years, so you have to pay attention to the problem. So we have an equation that represents the growth of a population of mice after T months. So pay attention, there are T's being measured in months. That's something you need to pay attention to as you're reading it. Part A says, what was the starting population of the mice? You should be able to just look at a number up there and tell me that that's the starting population. Which number up there represents the initial amount? 3. Isn't that A sub 0? That's our starting amount? Initial amount? So it's just going to be 3. 3 mice is what we started with.
So it's 8.
Part B says what is the percent the population of mice is increasing by each month. Which number up there represents that? The one in front of the T? That number there. Can we change that number into a percent? Can you change it to a percent?
8.95.
You gotta move it to 89.5%. That's the amount a population of mice increases by over time. That's a pretty high percent.
It's sick.
Alright, part C. What will the population of mice be after 3 months? Where am I putting that 3 months? That's going to go in for T. So I'm going to just plug that into the equation here. A is going to equal 3e to the 0.895 times 3. This should feel like what we did at the very beginning of the chapter. Remember when you could just plug it all in your calculator? This whole thing just goes in your calculator. And you tell me an answer. Should you have a decimal amount of mice? No. So you're going to want to round it
To the nearest whole.
to the nearest whole number. I believe if you plug it in, you should get 44 mice as your answer.
What, that comes in evenly?
Mm-hmm.
I don't have a calculator. Wow, disgusting.
You know there was a mouse in Bantam. There's mice all over the school.
Alright, guys, focus. Seriously. Part D. When will the population of mice reach 1,000 mice? Where is that 1,000 going in for? That goes in as A.
Okay, Kevin.
That's our new amount. We want to know when that new amount happens. So now this is where things you were doing yesterday should click in. How do I solve that? First, get the 3 away from it first. Divide by 3. That's 333.3333 equals e to the 0.895 t. Again, I'd like 4 decimal places in the middle of the problem, which if you just want to keep it in your calculator and then take the natural log of it, that would be fine, because that's what you told me the next step is, right? Natural log? Natural log, because that cancels out the e. 0.895t is equal to 5.809, I believe you should get. Yeah. 5.8091. Last step.
Where'd you get that?
Mm-hmm.
I just asked the really dumb question.
6.5 is what I'm gonna round that to. 6.5 what? Months, because that's what we were measuring time in here. So make sure you give me the right, accurate measurement based on what the problem said. So this one you have to find the equation all by yourself. So we're talking about the population in Africa. The 3 things you need to know to be able to find the equation are the initial amount, the new amount, and the time it takes to get there. So which one of those up there is my initial amount?
The
6 point.
That's A sub O, so 643. What is my new amount?
813.
That's A, 813. And then what is my
2000, or is it would be 1990?
time? You have to look at how much time elapsed from
10.
1990 to 2000. 2000 minus 1990 is 10 years, right? You should be able to do that in your head, but if you need to look back at your notes, you can at least see that where it came from. So the time is 10. That's how much time has elapsed to get to the new amount. Time is always how much time has elapsed to get to that new amount. From the first amount to the new amount, it's 10 years. So then, what we can do is we can plug into, remember that equation I gave you on that first page? A equals A sub O e to the kt. That's what you're going to plug into, and your goal is to find k. That's what we don't know. We don't know that the percent that this population is going up by. We're going to find it. So we're going to plug everything into there. So it's going to be 813 equal to 643 e to the k times 10. What do I do next?
You divide 6
Divide by 643. I get 1.2644 equals e to the, no, I did it on my calculator. E to the 10k. What do I do next?
you LN.
Natural log. That should come out to, oops, 0.2346 equals 10k. Last step. You just gotta move the decimal point, right? Because you're dividing by 10. 0.0235. Just give me 4 decimal places there. That's k. What did the problem ask for, though? It asked me to find the function. Is k a function? Is that the equation?
No.
So your last step here is to actually write out the equation with a as just a. That's your variable. You can plug any new amount in, but your initial amount is going to stay 643. So you're going to keep that. E to the, what did we just find k is? 0.0235. T, you can plug in any t you want. So you're writing the equation where you could plug in any amount you want or any t you wanted, and it would give you the answer. So you have to have the initial amount plugged in, and you have to have the k plugged in. So actually this should say plugging in k and a sub 0. I'm going to write that in up there in the box. So step 1 was to find k. We found k. Step 2 was to write the function plugging in k and a sub o and the initial amount. Step 3 is what they're going to ask us in part B, is now we can use that function to answer the next question.
Oh, so we just had to find the function.
That was the difference, is we had to come up with the function on our own. Now it says, by which year would the African population reach 200 million, or 2,000 million, which is the same as 2 billion. So where does this going to go?
A.
That goes for A. That's our new amount. Our new amount is 2,000. We have to solve this equation for it now. So the hard part is part A. Part A, you have to do a little bit of work. You have to find k, plug in all the numbers you know, find k, write the equation. Then the equation is just what you use to answer part B. Divide first, right? Make sure when you're dividing on your calculator with whole numbers, you put a decimal in it so it'll give you the decimal answer. This should be 3.1104
You mean like put a decimal at the end?
at the end of it, and then it'll give you the decimal answer right away, so you don't have to keep typing it back in. What am I doing next?
Log.
Natural log. Get rid of that E. Not the button I meant to hit. .1348 equals 0.0235t. And the last step, divide 0.0235. T is equal to 48.3. But notice it said by what year? Is that the year? What are we going to do with 48? Add it to, the original year was 1990. So you have to add that on. 2038.